Okay, so now we're going to start talking about graphing linear functions. And in order for us to be able to graph linear functions, we have to be able to work with them and find points and do all the stuff that we would normally do for graphing. So now we're going to talk about what we call function notation. Okay, it's a way that you will see frequently linear functions and other functions written. So this is another method for writing functions. Okay. It allows us to evaluate them without having to graph and without having to technically solve. All right, so just in case you ever have to worry about this as far as the way it's written, equations are for solving, functions are normally for graphing. Okay, when you have an equation that you're solving, it usually equals a number, right? If you have a function, then you normally have two variables, and one variable equals whatever the pieces are for the other variable. So big difference as far as equations for solving, functions for graphing. Okay, so we're going to talk about function notation and being able to evaluate functions. Okay, so y equals 2x minus 4 is a linear function. You could graph this, right, by substituting in numbers for x and getting out numbers for y, or the other way around. And there's also some ways that we can actually graph this without having to do as much substitution, and we're going to get into this in the next lesson. Okay, if we write it as, and this is read as f of x, f stands for function, the function of x, equals 2x minus 4. So the f of x is basically the same thing as y. It is what we call our output, right? Right there, output. When x is the input. Okay, so it's another way of writing it to where you are not graphing it. You're going to be evaluating it, working with it, and doing all other things. If you see them written as f of x equals 2x minus 4, more than likely you're not going to be graphing. You're just going to be evaluating and solving and doing other kinds of things. Okay, so f of x is the same thing as the y. It's your output, and x is your input. Okay, so we're going to evaluate. So if f of x, the function of x, is 2x minus 4, what is f of 4? That's how you would read that, f of 4. Okay, we are going to substitute 4 for x to determine what y is, or your output, right? That's all you're doing, is that you're substituting. Notice that 4 is in the parentheses. It's in the same place that x is. All right, so we're replacing x with 4 and figuring out what we get as far as an output. All right, so let's go ahead and do that now. Okay, f of 4 means we're going to do 2 times 4 minus 4, because that is 2 times x. Okay, so 2 times 4 is 8, minus 4 is 4. So my answer, my output is 4 when my input is 4. I could do another one, and I could say I want to do f of 3. Okay, so what is my output when my input is 3? So 2 times 3 minus 4. Okay, so when my input is 3, my output is 2. Right, and those can also, your answers could also be written as an ordered pair, because what we're talking about is points. When x is one thing, y is something else, and that's a specific point. All right, so let's try some more. Okay, if g of x, and yes, you can use g, the most common letters that you will see are usually F, G, and H, but it could be pretty much anything as long as there's the parentheses with the x there. They're giving your function a name. So if g of x equals negative 3x plus 9, what is g of negative 2? So we're going to substitute negative 2 in for x. All right, and so what we have is negative 3 times negative 2. So do that first, plus 9. So that is 6 plus 9. Okay, so that means my answer, when x is negative 2, y, or the output, is going to be 15. Okay, so let's try a slightly harder one. All right, so we have c of a equals negative 16a squared minus 5a plus 3. What is C of 2? So again, we're going to substitute. Now, the difference here is that, take a look at your function, you have more than one a, and you have to substitute that same number in for both of them because there are two a's in there. They're two variables, so you have to actually substitute for both. So negative 16 times 2 squared, right, because that's what my a is going to be, minus 5 times 2 plus 3. So we're going to simplify that out. Again, if you have to use a calculator, that's fine. Let's see, negative 16 times 4 is a negative 64. Minus 10, since we have to do multiplication and exponents first, plus 3, negative 51. So the output when C is 2 is negative 51. Okay, that is, oh, no, one more left. So we have to be able to talk about going in the other direction. So normally, we have like f of x equals 3x minus 2, and I say, all right, what is f of 3? You would substitute 3 for x, right? X is 3. Substitute it in and tell me what the output of the y is. Okay, so now I'm going backwards. If I say, what is f of x equals 10, then what I'm saying is that my y, or my output, is 10. What x gets me there? Okay, so in this, we actually have to do a little bit of solving since that's my output. So the function f of x equals 3x minus 2, I'm making f of x equal to 10. So I have the now equation 10 equals 3x minus 2, and I need to solve it for x. All right, so we're going to add 2 on both sides. Okay, 12 equals 3x, and then we're going to divide by 3, and we get x is equal to 4. So the right way to write that answer would be that f of 4 equals 10, because that was the output that they gave us, was 10, and we were trying to find what input would get us there. All right, that is it for function notation. And then we're going to start graphing.